Good morning, all. Let us discuss some of the numericals which were asked in the paper Basic Electrical Engineering in 2026, second semester. So I will draw the question, and very easy questions are there, tricky questions are there, as well as easy questions are there. Just you need to apply the tricks and you can solve it easily. Let us take one problem. This is question number 1B. Question number 1B. Let us try to solve this one. So here the question is, you have got a registers like this. So these are the registers, and the nodes are mentioned over here as this is one node A and another node is mentioned here B. So the question is asked that what is the equivalent resistance between node A and B, and the resistance values are 3, 2, 2, 3, 2 and 3. If the examiner would have asked the A and B as this as a node, you can have easily solve it. But here the examiner has asked the node between this point, that is A, and another is B. So you have to split this registers, or you have to add the series and parallel combination of the register such that A and B will be taken out. If you take out the point A and B, what you can do, you will find that these are the registers which are in series, right? You can see that these two are in series together. What I will do is, what we will take which one are the series registers, then we will try to combine it out. So these two are series register, so better to remove these 2 and 3 and write down these registers as 5, correct? Now this 5 and these 2 share the common node, right? So if they are sharing the common node, can we say that these two registers are in parallel? Possible, right? Because these two are sharing the common node. So we will remove these two and write this as a common node they are sharing. So we will remove that and we will say this is the common register. What are the registers we removed? 5, another is 2, 5 into 2 divided by 5 plus 2, because they are in parallel. So this will be 10 divided by 7. Correct? Now this circuit is now very easy. You have got one path like this between node A and B. Other path is like this. So these two are in series. Which two are in series? We can say that these two are in series and these two also are in series, right? So we can combine these two registers and make a simple circuit like this again, that there is a node B. It has got 2 resistance only now left, and this is the node A. 7 by 10, 10 by 7 plus 3 you can add up, and here it is 5, and here it is 10 by 7 plus 3, 21 plus 10, 31 by 7. So this side will be 31 by 7 and that will be 5. You can combine these two and parallel you can multiply and find that equivalent resistance is now RAB is equals to, it is coming around 155 divided by 66, which is equal to 2.34 ohm. Right? So only thing is that you have to use the trick that which two are in series, which is in parallel. That is why this carries only 1 marks. Let us go to the next problem. Here you have given what is the equation of the voltage. The voltage equation is given as 100 sine of omega t plus 90. Correct? And the current equation is 20 cos of omega t minus 30. Can you see what is the problem here? Here the examiner is asking by what the current is lagging the voltage. This problem is having one trick is here. The trick is that it is mentioned in sine and this one is mentioned in cos. So you have to convert this into any one variable. Either you can convert both in sine or you can convert both in cos. So if I will convert this current in terms of sine, it will be 20 sine of omega t. Same thing you write plus 90 you will write there when it is converted into sine. So this value will be equals to 20 sine of omega t plus of 60. So now you have got two equations. One is for the voltage, another is for the current. Correct? So since you have the two equations here, and the examiner is asking by what the current lags the voltage, draw the phasor for the voltage. What is a phasor? You can write V is equals to 100 angle 90 degree. And what is the value of the current? Current is equals to 20 angle 60 degree. Correct? So from this one can easily say the current is lagging the voltage by what degree? 90 minus 60, that is 30 degree. So easily you can say 30 degree is the answer. Correct? In this way you can solve. One can write the phasor like this. Also you can say, if you say the RMS values, you can write the phasor like this. Both are correct. In one case we are taking the peak value, another case we are taking the RMS value. This is more correct one. So that way you can find out what is the value of by what angle the current lags the voltage. Answer is 30 degrees. Okay, next problem. Let's take the next problem, the question number 2a. In question number 2a, let us take the question here. Question number 2a, what is the question? There is a voltage source of 15 volts in series with a resistor of 5 ohm. In parallel there is a resistor of 3 ohms, and other side there is a current source of 5 ampere in series with two resistors, that is one, another is 2 ohms. So this is a question, right? And the examiner is asking what is the current through this 5 ohm in this direction is mentioned here. So how to solve it? First, in this network you have to identify two nodes. Let us identify it here and here. One of the node you make it grounded. So this is the node which is made grounded, and this is a node let us say this voltage is VA. Apply the KCL there. If you apply KCL, you can assume all the currents which is going out of the node is equal to 0, correct? So all the currents means the current is here 1, 2 and 3. If you add this is VA minus 15 divided by 5 plus VA by 3 plus here plus 5 equals to 0. Because you have to add all the currents. Since there is a current source, no other current will flow there. Only the current which will flowing is the current in the current source, that is 5 ampere. If you add these, if you solve this, what will happen? VA 1 by 5 plus 1 by 3 is equals to minus of 5 plus of 15 by 5, right? 3. So this will go there. 3 and it will go to minus of 2. And if you try to solve this problem, you will get a negative voltage. That is, the answer of VA is coming around, VA is coming minus 15 by 4 volts. If VA is minus 15 by 4, you substitute the value of VA here, you will get the current which is going in the left hand side, let us say I1, this current is coming around minus 15 by 4 minus of 15 divided by 5. This current will come around 15 by 4 ampere, right? So if 15 by 4 ampere, that is nearly equals to 3.75 ampere. Why? Sorry, I1 is coming around minus 15 by 4. I1 is coming minus 15 by 4. You can substitute here negative value, so you get a negative value. The current I is the opposite of the current which is asked is I. So the current I is equals to minus of I1, that is equal to 15 by 4, and that is why it is 3.75 ampere. So you just need to say, remember that the answer will come as a positive value, answer will not come as negative value. The reason is you are finding this value of I1 and the examiner is asking the current which is going from the left hand side to right hand side. So for that reason, this answer is 3.75. Now the examiner asks the same problem, you have to solve by using Thevenin theorem, correct? So let me just zoom this. Okay, let me just keep it over here. Let us redraw the circuit. Same questions, let me redraw. You have got a voltage source. Then there is a resistor, here also resistor. Here you have a current source. Then you have got two resistors over here, 1 and 2. And here it is 5 ampere. Here you have 3, this is 15 and this is 5. Let us say, what is the examiner is now asking? What is the current through this 5 ohm in this direction? By using Thevenin theorem. So what Thevenin says that you removed the load from the circuit first. So let us remove the load from here. Okay, now the circuit look like this. After removing, you name the terminal this as A and name this terminal this as B. So you have got two terminals A and B. Find out the value of RTH, find out the value of VTH. So what is VTH? Let us say what is RTH? RTH is nothing but RAB. RTH is RAB. What is RAB? To find out the value of RAB, you have to remove this voltage source as well as current source and replace it by its internal resistance. Okay, let us redraw this. The internal resistance of voltage source is 0, so short circuit. The internal resistance of the current source is infinite. Rest of the thing will be as it is, 1, 2, 3, A, B. Now what is the resistance between A and B? The resistance between A and B will be this. What about these two resistors? These two resistors will be null and void because they are not connected in series, neither in parallel, so they are out of the circuit. So only resistance which is there is 3 ohms. Now what is the value of VTH? VTH is equals to VAB. How to find out VAB? To know the value of VAB, you have to apply KVL, Kirchhoff's voltage law. One thing, good thing is that you know the potential across this, fine. Okay, another thing is you need to know what is the potential across this 3 ohm. So we will use this circuit, we will not use, we will use this circuit because 5 ampere is flowing here. The same current is flowing in this wire because this side the current cannot flow because this is open. So the current is flowing in this wire. How much current will flow? 5 ampere. Other current will not flow because the current source is there, 5 ampere. So current is flowing from the lower to top. So you can say the sign will be voltage across the sign across the resistor will be like this. And how much current? 5 ampere. So what is the potential across the resistor? 5 through the 15. So this is 15, right? 15 volts. Now apply KVL and find out what is VAB. So VAB is equals to, first you encounter what? Plus. So 15. Then you encounter again plus 15. 15 plus 15 is 30 volts. Now what is the formula? The formula is that you have to find out what is the value of current, load current. The load current is equals to VTH divided by RTH plus RL. What is the value of VTH? The VTH value is how much? 30 volts. What is the value of RTH? RTH is 3. Now remember what is the load resistance? Load resistance is 5. So this side is 5. So this comes out to be 30 divided by 8, or I can say 15 by 4. And previously also we get 15 by 4. So that is 3.75. So right now you see that we have solved the same numerical, one by using node analysis, another by using Thevenin theorem. We must get the same answer, but the procedure is different. So this is the question asked in 2A and 2B, so that the student knows the procedure or not, that is checked. So 5 marks questions. So what they will evaluator will check whether the VTH is correct or not, whether RAB is correct or not, whether you have done the circuit for the RAB is not, yes or no. Then finally, did you get the value of IL with this equation or not? If you write all the procedures correct, you will get full out of full marks. Okay. Okay, next we go for the answer 3. A. What is the examiner is asking? It is a equivalent resistance. Okay, so there is a resistor. 3 resistors are like this. Another 3 resistors over here. And the resistance values are 3, 3, 3. This is 3, this is 3, this is 2. This is the question examiner is asking you, what is the equivalent resistance between the node A and B? Remember, one node is A, one node is B. So you have to find out what is RAB here. Very easy. But the problem is here, this is somewhere look like this network you have to redraw in a more better way to understand. Let me just redraw it once more. It is look like this. See that? This is 3, 3, 3. This side is also 5. This is 3. This is the terminal B and this is the terminal A. What you have to do is, here you have to convert that delta into a star. If you convert the delta into star, then this numerical will be very easy. You take the value, what is the value of this star? You can say RA is 1, this is 1. The examiner knows this conversion, like how to convert from delta to star, he can solve the problem. So if all this triangle is of equal value, one can easily find this value. Star resistance is 1/3 of that. So you will get the value as, if these 3 are 3, then you will get this value as 1, 1, 1. Okay. So we have to remove the other side. These resistors, let us remove. Now once we remove these resistors, now you will find that this circuit is very easy. See that? This circuit is now very easy. Only thing is that available is this star resistors are over here. Now once these star resistors are available, so how you can this is easy because these two are in series, these two are in series, this is in these two are in parallel. So we can add 1 and 6 is 5, the 1 and plus 5 is, this one is, we can add this is coming around 5 plus 1 is 6, the other side it is 4, and this side you have got A, and this is 1, and this side you have B. Now this entire problem can be easily solved, and you can get here 6 and 4 in parallel in series with 1. And you will get the answer is 3.4, or yeah, this RAB is coming around 3.4 ohm, right? So this problem is easy, and this is equivalent circuit question one asked. Next we have 3B. Okay. Let me write the question here. Here one resistor is given along with one voltage source. Then there is a 3 resistors are given here. That's all. Simple question. This is 3, this is 2, and this is 20 volts, and here is 3 ohms. You are asked, the question is, examiner is asking, what is the voltage VAB? That what examiner is asking, what is the value of VAB? How to find out VAB? Now this questions is again one of the very easy questions because here only one voltage source is there. You have to use KCL, KVL. So if you use KCL, KVL, you can find that you can draw the current first. KCL, KVL, that you will draw the current direction first. This is the direction of the current. One can ask that, sir, current will not flow in this side. Answer is no. The current way here is 0. Here there is no current. That is 0. Only the current will flow on the right hand side because the circuit is complete here. So what is the value of the current? The current is straight away you can find 20 divided by 8. This much ampere. Right? So 20 divided by 8 amperes. Okay, KCL, KVL, there is one, the sign is also to be mentioned. Sign convention is required. So sign convention means the voltage source is there, fine, voltage source is there. You have given the direction of the current clockwise. If you draw the direction of the current clockwise, accordingly you have to give the sign across each resistor. So you have to give a sign across these resistors, like this. Now the examiner is asking what is VAB. So move from A to B. So first is 3 into 0 because the current is 0. Next is 20 because first you see the plus sign, then you see the negative sign. Correct? This is plus sign, then you see the negative sign. What is the current? Current is 20 by 8. What is the value of resistor? Resistor is 3. So VAB value will come out to be 12.5 volts, right? So 20 by 8 can be also 10 by 4 or 5 by 2 ampere, that is 2.5 ampere. So 2.5 into 3 is 7.5, 20 minus 7.5 is 12.5. In this way you can easily solve the VAB and you can get the answer quickly. Okay. Next, we will go to the another problem, that is answer 4. A. Here you have got one resistor, inductor and a capacitor in series with a voltage source that is given as V is equal to 311.127 sine of omega t minus 30. The value of resistance is 10. The value of inductance is 0.02 Henry. The value of capacitance is 100 microfarad. Okay? The best way to do it is that first write down the value of the resistor as 10 ohms. What is the value of XL? XL is equal to 2 pi f into L. How much this will be? 2 pi f. What is the value of f? F is, so we can do 2 pi into 50 into L. L value is 0.02. You can easily find, and the unit of this will be in ohms. Similarly, you can find the value of XC. XC is 1 by 2 pi f into C. And if you put this value, you will get 1 by 2 pi into 50 into C. C is value how much? 100 into 10 to the power minus 6. So these values will come out to be, this is 6.28 ohms, and this side will be 31.847 ohms. So now you get the value of three values. One is the resistance. The inductance is given in terms of Henry. Convert in terms of inductance, inductive reactance. Similarly, you convert in terms of capacitive reactance. Once you convert this in terms of their reactances, it will be easy for you to calculate. Right, so we can just keep it aside because that will require the resistance value is 10, correct? Now, what is the value of the voltage? The value of the voltage is how much? Value of the voltage is, this value is the peak value. The RMS voltage is this peak value divided by root 2. You will find it is exact nearly 220 volts. Okay. Now the examiner is asking what is the current through the resistor. The current is very simple. The RMS voltage divided by R plus JXL. If you say plus, you have to write 1 by, or better to write in terms of, you can write J common, XL minus XC. Best way to solve it. You know the value of XL, you know the value of XC, 6.28. The value of XL is 6.28, the value of XL is 31.84. Obviously the answer will be in negative. Now what is the value? This can be written as 220 divided by 10 plus J, 6.28 minus 31.84, and you will get the value of in a complex number. And once you solve this, you are getting the value of current is 8.01 angle 38.63 as answer. So since the magnitude is only asked, so answer is 8.01. Nothing is given, angle is not asked. So if somebody is writing the current is equals to 8.01 ampere, correct. Now what is the voltage across the resistor? Obviously the current into voltage is 80.1 volts is the voltage across the resistor. I can say VR is equal to 80.1 volts. This is 4A. This examiner is asking the same numerical as there, is asking that at what condition, that suppose the input frequency you are allowed to vary. Suppose omega d is the frequency, you are allowed to vary the value of omega. At what condition the current through this will be maximum? So that is possible only if the inductive reactance is equals to the, That is possible only if the inductive reactance is equal to the capacitive reactance. So the current value for the first question is over here. So this is just to have a confusion, so we just remove this one. 10 ohm is given, okay, fine. So the examiner is asking that at what frequency the current will be maximum. We know that the current is equals to how much? The current is equals to V divided by R plus J XL minus XC, correct? This is the formula. If I will remove this term, then the current is maximum, because this is the only thing odd man out. So what is this term? XL minus XC. So can I write XL minus XC should be equals to 0. In this situation, XL is equals to XC, or omega L is equal to 1 by omega C, and I can write omega square is equal to 1 by LC. Omega is what? Okay, remove this square term, make it root over. Omega is 2 pi f. Write down f here, and the other part you can write down here. So now you get how this formula is coming. So he's asking that what frequency the value of current is maximum, you have to do like this. Put the value of L here, that is 0.02, and C here as 100 microfarad. Then you will get the answer here as the frequency at which the current is maximum is 112.61 Hertz. So this is the answer. 112. Again, is asking like at this is not it's a common sense that at resonance what will be the voltage across resistor, because at resonance these two terms are cancelling each other. Only terms is remaining is 10 ohms. So 220 volt will be across the 10 ohm resistor. So during the resonance, the voltage across the resistor is 220 volts. You will say the RMS voltage, 220 volts, right? So this is question number 4B. Okay, next we go for the question number 6. Question number 6 is basically, it is about energy meter. So in a household, it is assumed that a household is having a bulb, a fan, BLDC fan, a fridge, and AC is there, and the total bill the household, the person is interested to pay is rupees 600. Question 6, the total amount the person is willing to pay is 600 rupees only, and here he is using the bulb, this much number of bulbs. So let us see, he is using the, let us say, quantity, how much bulbs, and what is the wattage of that load he is using. So we will write down there, and the number of hours he is using that, approximately number of hours. So what is the value? So he is using, one is the bulb, each of 20 watt, LED bulbs are 20 watts, and for 5 number of bulbs and for 5 hours. If we use this, the value, the total wattage he consumes is 5 into 20, that is 100 watt for 5 hours. So 500 watt he is consuming in one day. So we have to write here, this is watt hour. So you have to, this value will be 500 watt hour per day. You can convert into kilowatt hour. If you convert into kilowatt hour per day, this will be 0.5 kilowatt hour per day. Next, he is using a BLDC fan, which is also of 20 watt. And each, how many BLDC fan? 3 BLDC fan, each of 20 watt. So totally 60 watt. How many hours? Fan is using for 10 hours. So obviously this value will be 600. If you convert into kilowatt hour, 0.6, correct? Next is, he is using a fridge. Fridge is of 40 watt. approximately, and one fridge, and how many hours? Fridge is actually used throughout the day, so approximately 20 hours. So how much is the total units, total in watt hour? It is coming around 800 watt hour, and in kilowatt hour it will become around 0.8, because you multiply 10 to the power minus 3, so that you can write kilowatt hour. The fourth one is, he is using AC whose wattage is 1.5 ton. 1.5 ton is usually 1500 watt. 1 ton, 1000 watt. 1.5 ton, 1500 watt. How much is his? Obviously one air conditioned one is there. How much hours? This is not given there. So we have to mention here X. Let us say X hour he is using. So how much watt hour? You can say 1500x or 1.5x. That is the total he is using. If I add these all, if I add these kilowatt hour, why I am using kilowatt hour? Because the money which is paid in terms of unit, the electricity bill is given in terms of how much unit you are using. 1 unit is equals to 1 kilowatt hour. 1 unit means 1 kilowatt hour. So how many units you have? So number of units is 0.5 plus 0.6 plus 0.8. 1.9 plus 1.5x. This much number of units in one day. In one day. For 30 days, into 30. Since the examiner is not given the month, so if a student is writing for the 30 days, it is okay. He is saying monthly bill. So monthly can be 30 days, it can be 31 days. So both the answers will be correct. So if you say multiply by 30, it is also correct. If you multiply by 31, this is also correct. So this is the unit, total number of unit which is consumed in 1 month. Units per month, that means the unit. This is it. Okay, not need to write here. This is this much number of units is consumed per month. So electricity bill is calculated how? So first let us multiply this. So 30 into 1.9, this is coming around 57 plus, and this is 45x. So this is the number of units it is coming out. Why I multiplied, I will tell you now. Because the unit, the amount that you are going to pay is not fixed. It is the first 50 unit you have to pay in terms of 2 rupees 90 paisa. If you see your household, you will find that if you see your electricity bill, you will find that the first, how much unit we get here? 57 plus 45x. The first 50 unit, let us calculate the rupees you have to pay. First 50 unit you will pay in terms of 2 rupees 90 paisa for first 50 units. Rest 7 plus 45x you have to pay in terms of, the next amount is 4 rupees 70 paisa. The first 50 unit you have to pay as 2 rupees 90 paisa. The rest you have to pay is 4 rupees 70 paisa. If you solve this, you will get, what is the total amount to pay? 600. So just this equation you need to solve. The total amount of rupees this paying is 600. So you have to just calculate this linear equation, and once you calculate this, you will find the value of x to be 1.995, this much number of hours that you are going to turn on the AC. That nearly 2 hours you need to turn on the AC. If you exceed 2 hours, the electricity bill will be more than 600 rupees. If you run for below 2 hours, the electricity bill will not exceed 600 rupees. So this is one of the interesting problem that if you fix the household, how much expenditure you have to fix the expenditure. So how much hour you can turn on the AC per day, you can reverse calculate, and accordingly you can use the AC and you can save the money. So these are some numericals we discussed from the semester question. Thank you. All the best.